Okay, this is our last one for today, and we're going to be looking at naming with polyatomic ions. And the good news is that this one right here is definitely a little bit easier than the stock system naming that we just looked at. So we talked about polyatomic ions back when we were discussing bonding this past week and last week. And key things to remember about polyatomic ions is it is a group of covalently bonded atoms. Okay, so think about SO4 with a -2 charge. The sulfur and the oxygen are both nonmetals, which we understand as a covalent bond. However, they do take on a charge because they're very attractive to certain electrons, which is why we see that ion word there. So, let's say that you see something like this. Let's kind of talk through this. We see lithium, which we know is a metal, and then we see nitrogen, who's a nonmetal, and oxygen, who's a nonmetal. How do you name something like that? Well, what you're going to start realizing is you're still going to name the lithium like we've been doing. But notice what this NO3 is. This NO3 is a polyatomic ion. It is two nonmetals bonded together. And you actually have two different lists to kind of look at. This right here is one that you were given today, and they are all on their alphabetical. This can be a little bit overwhelming, and actually for right now, you can actually ignore that right there. But you would look over here and try to find N. You also have this list, which you'd be looking at the polyatomic ions are all right here, and they are organized by charges. So all the plus and minus ones here, the 2 and 3s here. And when you find NO3, you're going to see that it's called nitrate. And so literally all you have to do is name the metal, which is what we have been doing, lithium, and then name the polyatomic ion, which would be nitrate. And so this is really about getting yourself in the habit of recognizing those polyatomic ions. In Honors Chem 1, you will not have to memorize the polyatomic ions, but beware, you will be doing that in Chem 2, so it doesn't hurt to try to get used to them now. This next example is actually kind of a little bit trickier than what I would expect on the front end here, but you see nonmetal, 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 nonmetal. And so this is nonmetal, nonmetal. This is actually a polyatomic ion, and this is a polyatomic ion. So go ahead and hit the pause button on your video and take a look and see if you can figure out what these two polyatomic ions are. What's confusing on this is that even though they're both ions, this one is actually a +1 and this one is actually a -1, which is why we can still use the same naming that we've been doing. And so this would end up being called ammonium. NH4 is called ammonium, and OH is called hydroxide. Ammonium hydroxide is our name there. Okay, let's take a look at another one. This is KClO. So again, notice that there's that metal, non-metal, and non-metal. So right off the bat here, you should in your head be thinking ionic, because you know that this potassium has a +1 charge, and then you know that these guys are covalently bonded. So what would this be? That's a polyatomic ion. You would need to look at your sheet and find ClO. Okay, take a look at your sheet and find ClO. We're going to name that first metal potassium, just like normal. And then when you find ClO, that is called hypochlorite. Pay attention to that ITE there on the end. Okay. So these first three examples, we've been looking at the formula, and then you give the name. Let's take it to where you're given the name and you have to supply the chemical formula, which is what we probably need to be more familiar with anyway. Copper 2 sulfate. Okay, I've kind of thrown a little bit of a doozy here at you. We see copper, and we see that too, and we just got done talking about stock systems, so think that is telling you there that the copper in this is a +2. Hopefully you remember that. Sulfate. This is not sulfur, and the way that you know it's not sulfur is it ends in ATE. If you see ATE or ITE, okay, ATE or ITE, it's telling you that it is a polyatomic ion, and you need to be looking at your sheet. When you look up sulfate, you're going to see that it is SO4 with a -2 charge. And so now what is going to be the chemical formula when this copper and this sulfate come together and combine? What ratio are they going to form in? Simply CuSO4. You need one sulfate and one copper because those charges cancel each other out. Let's take a look at this next one, potassium dichromate. Again, we know that potassium is represented by a K and it has a positive 1 charge. Dichromate. You're sitting there going, I have no idea what element that is. Okay, well, you don't have to because it ends in ATE. Look at your chart and find dichromate. And when you find dichromate, you're going to see that it is Cr2O7 with a negative 2 charge. And so now the question is, how do you get the negative 2 and the positive 1 to cancel out? Well, we need 2 potassiums here. So your chemical formula would be a subscript of 2 on the potassium, and then that Cr2O7. Those polyatomic ions are never going to change. That is just going to come straight down. And we're going to look at a couple in a minute where you have to add parentheses because you actually change the subscript on those. So let's go ahead and switch over and do a couple more practice problems before you work on some of these. Let's take a look at barium phosphate. Okay, again, we see barium. We know barium's a metal, and if you look it up on your periodic table, you're going to see that it's a +2. Then we see phosphate. Notice that it ends there in ATE, which is telling you that it is a polyatomic ion. So at that point, you would want to come over here, look at your sheet, find it on your sheet, and you can see that phosphate is represented by PO4 with a negative 3 charge. Now this is still ionic. We still want those charges to cancel out. So we have a positive 2 and a negative 3. How can we get those to cancel out? Let's try to get both of them to 6. And so here's what we talked about the other day, that to get this to 6, you're actually going to need 2 phosphate ions, and you're going to need 3 bariums. So in writing out that chemical formula, we're going to put a subscript of 3 on the barium. The phosphate right here, be careful. You've got to add parentheses around that phosphate and then put your subscript of 2 on the outside. If you were to write it like this, look at what this looks like. So there's that phosphate, and you say, I want 2 of them. That's not right. That's 42 oxygens. That is not right. So we have to add that parentheses to say that we want 2 of these phosphates, 2 PO4s. Let's take a look at the next one, chromium 2 nitrite. Do not be afraid of that Roman numeral. You should actually get excited because that's kind of like your cheat there. We know that the chromium is automatically a +2 because that's what that Roman numeral is telling us. Sorry if you can't tell if that's a 2. And then we see nitrite. Notice that ITE. That ITE is telling you that it's a polyatomic ion. So you can look at either of those sheets that I gave. You've got 2 here. You see nitrogen. Okay, so it's going to have something to do with N. And if you look it up, it is actually NO2 with a negative 1 charge. So here we have chromium, who's a positive 2, and nitrite, who's a negative 1. So what do I need here? How many nitrites do I need to get rid of that positive 2? I need 2 of them. So we're going to write that as 1 chromium and then 2 nitrites. And that's what that subscript of 2 right there on the outside is telling me. Moving on down, this one we're given the chemical formula. I have to come up with the chemical name. Excuse me, the formula. We're given the formula, we're asked to come up with a name. Keep this simple. Call it exactly how you see it. There's a K there. What does K represent? K represents potassium. Potassium only has 1 possible charge, so there's no reason for a Roman numeral there. It's not a stock element. And then you need to look up and see what SO4 is. And when you look that up, which you should be doing right now, you're going to see that that is sulfate, ATE. If you were to accidentally write sulfite, ITE there, that would be wrong, okay, because sulfite is a completely different polyatomic ion. That, apparently, we are about to look at. Here we see calcium. So again, write it like you see it. Calcium. And then right here, see that SO3? That's very unique. You've got to look to your polyatomic ion list, and when you do that, you're going to see that that is sulfite with an ITE there. So these are really not that bad to name at all. It's just getting used to when to use what rules and things like that. And then the last one that we have is zinc. Zinc is always a +2. So we're going to write it in as zinc. Notice that ATE. So we're looking for chlorate, and if you look over at your polyatomic ion sheet, you're going to see that chlorate is represented by ClO3, and it has a -1 charge. This is ionic. We've got a +2 and a -1. We want them to cancel out. So how many chlorate ions do we need? To get rid of that +2, we need 2 of them. So you would end up with zinc, parentheses, ClO3, and then a subscript of 2 outside of there to show that we want 2 chlorates in order to cancel out that +2 on the zinc. I hope that helped, guys, just hearing it explained, each one, and let me just know what questions you have.